Hello, this is Dr. Grande. Welcome to my video on testing the null hypothesis using ANOVA in SPSS. As always, if you find this video useful, please like it and subscribe to my channel. I certainly appreciate it. I have here in the SPSS data editor fictitious data. I have an independent variable named program. This has three levels: individual, group, and treatment as usual. So this is individual counseling, group counseling, and whatever treatment was in place before the study was commissioned, the treatment as usual. And then we have a dependent variable named functioning, and this is measured at the continuous level. And here, with a setup like this, an independent variable and a dependent variable, usually we want to test the null hypothesis. The null hypothesis states that there is no difference between the groups, and in the case of ANOVA specifically, that the mean on this dependent variable for all the levels of the independent variable is equal. The means are equal across the groups, across the levels. So in this case, with the independent variable program, we would say that all of these levels, all three of these levels, individual counseling, group counseling, and treatment as usual, were equally effective as measured on the functioning scale. Whatever instrument was used to measure functioning, there would be no difference in the means across the groups. So to run ANOVA here and to test the null hypothesis, I'm going to go to Analyze, General Linear Model, and Univariate. Now ANOVA does have several assumptions, and I'm not covering those assumptions here except for the homogeneity of variance, which I will take a look at because it involves another test of the null hypothesis. So in the univariate dialog, I'll move functioning over to dependent variable and program over to fixed factor independent variable. And because we have three levels here of the independent variable program, I am going to want to run a Posthoc test for the program independent variable. In this case, I'm going to run a Tukey test. That's a test, one of the tests that we would use when we have equal variances assumed. And again, I'll interpret the results of the homogeneity of variance test we use here in ANOVA, in this case the Levene's test. Press continue, and then to run Levene's test, go to Options, and I want to add in display, down here in this display frame, I want to add homogeneity tests. Click continue. Then to conduct the ANOVA, I'll click OK. And we have here the output from this ANOVA. So when we consider the null hypothesis for ANOVA, we're going to be looking down at the tests of between subject effects. However, before that, taking a look at the homogeneity of variance assumption, we have another null hypothesis that we want to test here under Levene's test of equality of error variances. And this test tests the null hypothesis that the error variance of the dependent variable is equal across groups. It tests the null hypothesis that we have homogeneity of variance. So when looking at this p-value, which is right here in this table, 0.158, this is a non-statistically significant result with an alpha set at 0.05. Now we set the alpha in advance. The alpha of 0.05 is fairly common in the social sciences. Other common alphas would be 0.01 and 0.001. 0.05 is the most common, that's the one I'm going to use here, and 0.158 is greater than 0.05, so here we would fail to reject the null hypothesis, or we would accept that the null hypothesis is in fact true. So we have homogeneity of variance because that is the null hypothesis. Now moving down to the tests between subjects' effects, we're going to interpret this row identified with program. So the third row down. And again, looking at the probability value, here it's 0.004. Now that is below 0.05, and that is statistically significant. So we're going to reject the null hypothesis that the mean is equal for all of the levels of the independent variable program. So we would assume there is a difference in the means across the groups. This is a statistically significant finding. Now with this result, with a statistically significant finding here for the independent variable program, we know that there is a difference in the means, but we don't know where the difference is because we have 3 levels of the independent variable. And that's why we have a Posthoc test. In this case, I selected a Tukey test. This is Tukey HSD. HSD stands for honestly significant difference. And this test adjusts the p-value for multiple comparisons so we don't get an increase in the type 1 error rate. The type 1 error rate is the probability of rejecting the null hypothesis when it's actually true. So saying there's a difference between the levels of an independent variable when there's not actually a difference. So here we have 3 p-values: individual compared to group, individual, treatment as usual, and group and individual. And you can see here that we have, for individual and group, a p-value of 0.05, and for individual and treatment as usual, 0.003, and group and treatment as usual, 0.546. So this value, 0.546, that is not statistically significant. So we would fail to reject the null hypothesis in this case, and we'd say there's no difference between treatment as usual and group, no difference between the means of those levels. Between individual and treatment as usual, we have a statistically significant result, 0.003. However, between individual and group, here in the output, we have a value of 0.05, and the alpha is 0.05. So the question becomes, do we reject the null hypothesis if the p-value is exactly 0.05? Well, this is something that you would set before you conduct the statistic. You would decide if you're going to reject if p is less than 0.05 or p is less than or equal to 0.05. So you decide that beforehand, and then you take a look at the result, and if you decide it's less than 0.05, you interpret it that way, or less than equal, then you interpret it in that manner. I deliberately arranged these data to get this result of 0.05 to demonstrate that point. However, it's important to recognize if we double click here, in this particular case, the table is set to return 3 digits to the right of the decimal. And if you double click on the p-value, you can see this p-value is actually 0.049677. So it would be statistically significant whether we're using p is less than 0.05 or p is less than or equal to 0.05. So in this case, we would reject the null hypothesis that the means are equal across these 2 levels, and we would say that they are not equal. But the mean scores on the function dependent variable between the individual and group levels of the independent variable program. So in this case, we have a statistically significant result between individual and group, individual and treatment as usual, and a non-statistically significant result between group and treatment as usual. I hope you found this video on testing the null hypothesis with ANOVA and SPSS to be useful. As always, if you have any questions or concerns, feel free to contact me. I'll be happy to assist you.